Namaste. Hope you are doing well. Today we'll tackle the ninth problem of ISI MSTAT 2023 PSB, the subjective question. So a key part of subjective questions is extracting information that is actually going to be useful in solving or writing the answer. And prerequisites over here are just spoilers. I'm not going to go much into them right now in the beginning, but do note that NPL means name and Pearson Leva. LR means likelihood ratio. So if you notice, it seems to be a hypothesis testing problem. You are given X size, X sense. There is some background context about that over here. And an important thing to note is mu and sigma square are known, which means they are constants in this problem, not parameters. Only rho is the parameter. And the most important thing, even though it started with Xi and then Yi's, it then gave you a twist that you don't have Xi's and Yi's. You have Ui and Vi. And then it asks about these two things, obtaining the test statistic corresponding to most powerful test and the critical value of that relevant test. So, I did this here itself. So, moving on. We extracted these relevant data. In your answer, while writing the answer, you can make a mental note of this or just write it in rough so that you know that you were given Xi's and Yi's, but then you realize that Ui and Vi was actually that you could use, and then it's a hypothesis testing problem. So all of these paragraphs summarized into this. This is the key extracted relevant data. Now connecting some dots. Obviously, we need to have some info about Ui's and Vi's, their distribution. Xi's and Yi's are bivariate and normal, might have been very easy to deal with. There are standard tests, but they are not available. Ui's and Vi's are what we have. So we need to link them with Xi's and Yi's. And once we have that link, can we make that link even better? So essentially the link is this. You see that Ui is the maximum, Vi is the minimum. But if you add maximum and minimum, it is the same as adding the two. So Ui plus Vi is Xi plus Yi. And more interesting is Ui minus Vi. So whenever you subtract these two, this is always going to be positive because maximum minus minimum, that's going to be positive. So it's equivalent to taking the modulus of the original two variables. And because of this information that we have for both of them, we can see that by the linear property associated with normal distribution, the means are added and the variances and the relevant covariance. So we have the distribution. This is the way to connect them. And is there an easy one-to-one transformation of Ui and Vi? Well, the clue was here itself. It's this. And that is because we have independence. Notice that the covariance of Ui plus Vi and Ui minus Vi is the same as this. Now, for a moment, ignore the modulus and look at this covariance. These two last terms will cancel out. And because the variances of Xi and Yi are the same, they cancel out. This means Xi plus Yi and Xi minus Yi. These two are independent normal random variables. And because they are independent, these two are also independent, which means Ui plus Vi, Ui minus Vi are independent, and they are going to be perhaps the easiest random variable transformation to use to get the test statistic. Now we have a good base with this, and we can go with computation. And then we'll use the Neyman Pearson lemma for that. Because we need to figure out how do we go about this most powerful test. And what that lemma simply states, and this you can write in the answer, is that when you're dealing with simple hypothesis, then the likelihood ratio, the test based on likelihood ratio is the most powerful test. Now let's see how this one line is going to give us the answer. The likelihood is essentially the joint distribution. Let's start with one observation. Note that AI is the observation Ui plus Vi and Bi is Ui minus Vi. Because they are independent, this joint distribution can be broken as the product of marginals, and then you have normal distribution form here and here, pretty standard. Then you take things common, essentially the numerator, because that part has the statistic juice. Others are constants in the denominator. So you focus on this. You can just write that it's proportional. You need not write the whole joint PDF again and again. Okay, so you have the likelihood. But now you need to find the likelihood under H0 and H1, because then you would get the likelihood ratio. Under H0, P equals to 0, you put that in over here and this just disappears. And H1 P equals to 0.5, same, you put that over here and you get a structure like this. Then you just take the ratio. Do note that in the likelihood ratio, we have the null hypothesis based likelihood in the numerator and the alternate hypothesis based likelihood in the denominator. The ratio simplifies in proportion to this. Okay, so that was one observation, right? But we want our test to be based on all observations. So what do? Take the complete likelihood. And that is going to be the product of individual likelihoods, LR1 all the way multiplied up to LRN. And when stuff like this multiplies, because it's an exponent, it would end up, the product would end up having a summation. There would be other things, but the main juice, the statistics, the random variables, they are concentrated over here itself. So it suffices to say that this is going to be our statistic. Let's take a note of it. It's put on the top right corner as well. So part A is done. This is our statistic. Notice that at the end, the AI and BI was replaced with UI plus VI and UI minus VI. Okay, you have it. Now, you have to find the critical values. So for that, you have to compute probabilities. To compute probabilities, you need to have distribution under the null hypothesis. Now, we already can see this because of the distributional property we observed. But there's a square. So we need to have them in square. And it shouldn't be much difficult because the square of normal, standard normal, is chi-square. So under H0, thankfully, rho becomes 0 and is eliminated. So these two end up being standard normal and their square is chi-square. So that's good. Our test statistic is a sum of stuff which is chi-square. And another thing to note, which direction would the critical value be? As in, how would you reject the test? This comes quite intuitively because the likelihood ratio has our test statistic raised to the negative. This means the higher this value goes, the lower this entire value goes. And so a higher value of our test statistic will reduce the likelihood ratio, and hence it means less evidence for H0 because H0 was in the likelihood coming from H0 was in the numerator. Remember that. Now, maybe you already see where this is going. The very spoiler section, very first spoiler section may be in your mind still. Expectation and variance. You have to find that and then use central limit theorem. Because this is chi-square with degree of freedom 1 and this is chi-square with degree of freedom 1, by linearity of expectation, this becomes 1 by 3 into 1 minus 1. Because expectation of chi-square with degree of freedom 1 is 1. And for variance, because this and this are independent, the variance, the computation of the variance is going to be the same as variance of this component plus variance of this component. And variance of a chi-square variable with 1 degree of freedom is 2. So we have the expectation and variance under H0. So when we plug this expectation and variance into the sum structure, we get this, that the expectation of t is 2 by 3n and the variance is 20 by 9 times n. Then we use the central limit theorem, and that quickly can give us normal distribution convergence, standard normal distribution convergence. And we can use we can use central limit theorem because this entire unit can be perceived as one random variable. So it is essentially the sum of n random variables which are identical and independent. Hence, central limit theorem can be used. And once we have the distribution convergence as standard normal, we can say that this probability will go to 0.05 when n goes to infinity, because this part here under H0 is standard normal 0,1, and this part here is the quantile of standard normal, beyond which the area is 0.05. So this is how it's. You need not even, with alpha equals to 0.05, you need not even know this value. Just stating it makes sense in the question. Then you can simplify this expression even further to have just the test statistic on the left hand side and the sort of critical value on the right hand side. And that's it. This was our test statistic, and this value is the critical value beyond which, if the observed value of test statistic falls, we would reject the null hypothesis. And as the sample size goes to infinity, the size of the test, which is this probability, will go to 0.05. So it's already written. And some base, to build your base, is to be open to the possibility of using weird looking stuff like polar opposites, maximum and minimum. Because at the start of the question, it may have seemed that we have to do something separately with maximum, separately with minimum. But when we combined them and made one-to-one transformations, ui plus vi and ui minus vi, things turned out pretty nice, and an IID setup was generated. So when you are faced with polar opposites, which in statistics exams are going to be maximum and minimum order statistics many times, try to see if you can combine them together and make the problem simplified. And if this was helpful, then the request is try to find out the correlation between the first and second pleasant things that happened with you today. Take care. Hare Krishna.